graph the function f of theta is equal to 1/2 cosine of 2 theta plus pi over 2 minus 2. First, let's identify A, B, C, and D. Now we can write down the information that we know just from this function. Well, remember that our amplitude is equal to the absolute value of A. Since our A is just 1/2, our amplitude remains as 1/2. Since this is less than 1, that means we're going to have a vertical shrink. Now for our period, by definition, it's 2 pi over b. In this scenario, our b is 2, so this simplifies to just pi. Notice how in our original cosine function, which is graphed here in black, the period is 2 pi. But in this instance, the period is only pi. That means it is only going to take half the time to make one complete revolution for this new function. Now let's consider our horizontal shift. Here we have a plus pi over 2, so that means we are actually going to be moving to the left. To figure out how far to the left, we do our c, which is pi over 2, divided by our b, which is 2. I'm going to rewrite this up here using my dividing rules for fractions. So I do same of pi over 2, change to a multiplication sign, and flip to 1/2. And that is equal to pi over 4. So that means my starting point is going to be negative pi over 4, because I'm moving to the left by that amount. Finally, we're going to notice our vertical shift, which is minus 2, which means we're going to be moving down 2. So let's do that. And we're here for negative 2. And I'm just going to make a horizontal line across at this y equals negative 2 line, because this is now our new x-axis for the function. So this means that this is what the cosine curve is going to oscillate around. Now that we've graphed our new x-axis, why don't we consider our amplitude? Since that's 1/2, we're going to go up 1/2 to negative 3/2 and down 1/2 to negative 5/2. Now that gives us our range. And for the range, first you list the lower end of your function, so the more negative number in this case, which is negative 5/2. And it goes to the highest, or the most closest to the positive number in this, which is our negative 3/2, because it's less negative. Now let's start by graphing our starting point for this. Well, remember that we are shifting over to the left to negative pi over 4. So if this is about our negative pi over 2, then this would be negative pi over 4. Recall that for a cosine function, the pattern is up, middle, down, middle, up. So we're going to start our first point at the upper point in our range. So that is right there. We can find our end point for this function by doing our value of our starting point, so that's negative pi over 4, plus our period, which is pi. We have to make a common denominator, so we get negative pi over 4. Sorry, couldn't really read that. 4 plus 4 pi over 4. Now I'm going to rewrite that so that we can see a little easier that this is actually 4 pi over 4 minus a pi over 4. And that is equal to 3 pi over 4. That means our endpoint for this function is 3 pi over 4, which It's just about there. And remember, it goes up, middle, down, middle, up, so it ends on the upper part of our range, so just about there. Notice how in the original cosine curve there are 5 points that we must consider, are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since we are translating and transforming this function, we need to make sure we do that as well for these 5 points. We've already found the first and the last one, so to find the 3 in the middle, what we do is we take our period of pi and divide it by 4. I'm going to write that like this, but that is equivalent to pi over 4. Because if you divide something, you're really putting it in a fraction. So that means each time it's going to increase by pi over 4. Making our 3 other points at 0, pi over 4, and 2 pi over 4, which is also equivalent to pi over 2. Perfect. Now we are ready to officially graph this function. So remember, we have up, so now middle point is going to lie right here, and then down, middle, and up, and we've already graphed that point. So I'm going to just connect these points and make arrows at the end because these are continuous functions that go on for infinity. And there we have it. We have officially graphed f of theta is equal to 1/2 cosine of 2 theta plus pi over 2 minus 2.